I want to welcome you all to our second Water UCI colloquium of the 2017-18 academic year on supplementing Southern California's water supply through seawater desalination, challenges, and opportunities. I'm going to go into some detail about our colloquium this evening and introduce our guests, our speakers, one at a time. But before I do that, I want to acknowledge some very important business this evening. I first want to recognize Valerie Glass. Valerie, if you could identify yourself. Valerie is a generous supporter of our colloquium series here in Water UCI, and we're very grateful for your generosity and making this program possible. We look forward to continuing to work with you in years to come on our colloquium series. Thank you very much for your support. Second announcement, very quickly, we were going to show you a very short video on our middle school water conservation challenge. This is an important outreach activity of Water UCI, working with middle schools here in Orange County to work with students and teachers on water conservation projects. They're middle school students today. In a few years, they're going to be the people, hopefully, managing and administering our water resources in California and beyond.
This program is Water UCI. It's a partnership with local middle schools where we go in and we talk to the students about the California drought.
We help them learn about what their water usage looks like and how they can change that in their community.
The other aspect that the program affords in terms of teaching students about the drought is in terms of helping teachers meet California state requirements on science and environmental education.
So yesterday, when you guys were listening to Gina from UCI talk to us about the UCI water project, she told you a little bit about the circumstances that we are facing right now in California with the drought, with not enough water.
The middle school program progresses the goals of Water UCI by helping us educate a new generation of water leaders to take a group of very highly motivated teachers and students and to come up with really imaginative and creative solutions. One of the students came up with a steam-powered dishwasher.
And she was saying, well, why can't we do this for our dishes? How come we can't create a dishwasher that operates by steam instead of water?
And would basically sterilize the dishes and then allow them to dry. It was a really creative idea.
My favorite part of the assignment is probably learning about how the drought impacts California and how people can come together and solve it.
I think it's a very beneficial program for the students, and it's different than what we normally do, and so for students it's different from the norm, and it's more exciting that way.
They love being able to display publicly what they've come up with. The parents are very proud of their students for what they've been able to accomplish. And the feedback we've gotten from the undergraduate students is also very positive.
One of the best parts of being involved in Water UCI is getting to interact with people. It's a skill that I think is somewhat understated in our graduate degree.
It's been a really nice experience, and I really look forward to volunteering in the future.
They're learning how to take what they learn here in the university and apply it to the needs of our public education system.
It's a great way to connect local schools with local universities and letting students have a chance to see what they could become and see where they could eventually go with their education.
Well, you never know where the next great idea is going to come from, and sometimes that's from collaboration with people you never usually interact with. And this program gives that opportunity to really get into your community and come up with some new great ideas.
We can develop a framework for making sure that the next generation of young people that will advance through high school and to universities and colleges will be prepared to understand the very critical connections between water and everything that makes California great. And I can't imagine how anyone could not see the value in that for the future of our state.
Having said that, I also want to acknowledge that after our colloquium tonight, we are going to have a reception in honor of our speakers, so please stay around, have a chance to have some informal conversation. And then the final announcement is on the logistics for this evening. I will introduce each one of the speakers one at a time, who will give a short, approximately 5-minute assessment, or I guess you could say a perspective on desalination from their experience and their training and background. And then I will pitch one single question to them that has been prepared in advance. At that point, I'm going to have them all come up to the table. And while this is going on, Shannon, if you would identify yourself, she's in the back. Shannon is going to pass out some cards for all of you in the audience to write questions, which will then be passed to the middle and collected, and we'll have a Q&A session in that way after the talks, okay? Everybody ready? All right. So, first of all, as you know, the use of desalinated ocean water to supplement California's limited water supply is an often contentious proposal. And we are very pleased to have a panel of experts, leaders in desalination technology and policy, who will be discussing the challenges and the opportunities associated with the use of this technology here in Southern California. I first want to welcome to the podium Professor Newsha Ajami, who is the Director of Urban Water Policy at Stanford University. Come on up.
I am a graduate of this school, so it's always a pleasure to be here. I also should say my faculty advisor is sitting here, so I'll be very nervous presenting. I want to talk to you a little bit about what we do and how it relates to desalination. It will be a quick talk. You know, climate change is changing our water cycle and urbanization, as well as aging infrastructure, and also the environmental externalities, all sort of putting extra pressure on our water supply and water cycle, urban water cycle. So there is a lot of focus on how can we survive in the next 100 years, and what kind of water supply portfolio do we need to have in order to be able to, for our cities to grow, to have a sustainable future, to have resilient communities. And my group actually focuses a lot on these issues. We sort of talk about traditional water supplies, you know, imported water supply, all the dams and aqueducts, and how you bring water to long distances, and how those are having a lot of problems right now, and how we need to diversify our water supply portfolio. And as you diversify, you need to rethink and reevaluate what do we need to do to encourage and to sort of help to implement some of these innovative solutions, and what kind of data and information do we need to acquire. So we work a lot on permitting, using big data. We work on these sort of financing and innovative financing for some of these solutions that are in hand. And desalination is one of those solutions that we are looking at through these different lenses: water-energy nexus, financing, permitting, how it's going to change our demand portfolio, how it's going to change our supply portfolio, and what kind of reliability and resiliency measures do we need to have in order to have to make sure some of these solutions that we are implementing would solve some of our existing water supply problems. Is that short enough? 5 minutes? Good? Perfect.
Our next speaker is Jeremy Crutchfield, who is with the Facilities Planning Group at the San Diego County Water Authority. Jeremy, come on up.
All right. Thanks again, and it's an honor to be here today to present. I kind of see my role on this panel as being the view of the water retailer or wholesaler in the case of the Water Authority. Our agency has implemented seawater desalination into our portfolio of water supply, and also looking at future desalination opportunities for our region. So this is a slide that every single presentation somebody gives from the Water Authority, we start with this, and it actually does apply to what we're talking about today. There's a quote that I like that says you have to understand, you have to know the past to understand the present. And I like to add to that and then blindly guess what the future is going to look like. But in 1991, the chart on the left up here, upper left, is where we were back in the early 90s. And as you can see, the yellow here is imported water from Metropolitan Water District. So we were pretty much a one supply, one source for water supply. They provided 95%. And back in the early 90s, there was a severe drought in Southern California. And that severely impacted not only our customers, but also just the economy in general in San Diego, because there were large water cutbacks. So we were looking at 70, 80% of our normal water supplies being significant reductions in our normal supply. So our board made a decision at that time that we would not go through that again, and then made a decision to invest significant money into new infrastructure to diversify our water supply portfolio. The bottom left is where we currently are, 2017, and since the early 90s, we've added water transfers. Our region has invested in water recycling. We also now have added desalination, canal lining projects, just different areas where we could guarantee water rights or achieve water rights and diversify our supply portfolio. As we move further into the future, desalination is on the table. The big next chunk that we're looking to invest is from the city of San Diego, and that's potable reuse. So there are obviously a multitude of supply opportunities and supply options, and it's a matter of guiding what's the best one to move forward to in the future, and that'll be a focus of this panel. So why desalination? For us at the time when we started looking at the Carlsbad plant, really it was we wanted to have a new locally controlled supply of water, one that couldn't be impacted by allocations, environmental impacts in the Bay Delta, drought in the Colorado River. We wanted to have new local supply in San Diego, and this is now a drought-proof supply. That's one of the advantages of seawater desalination. It also had a very strong support at the time. Potable reuse was kind of a new thought back then, but the public was not behind that concept at all. Now it has since changed, and hence why we're moving toward that direction now. But desalination made sense back in the late 1990s when we first started contemplating bringing desalinated water to San Diego. So our current plant is the Carlsbad Desalination Plant. This is a public-private partnership with Poseidon. And Scott will be, he's representing Poseidon on another project, but we are partnered with them down in Carlsbad as well. We've entered into a 30-year water purchase agreement with them where we are the sole off-taker from this plant. They produce anywhere from 48,000 acre feet to 56,000 acre feet a year. It's a 50 MGD plant. It was a $1 billion investment, and then the financial and delivery obligations are all controlled by our water purchase agreement with Poseidon. It was a 15-year project to get it from planning and permitting, design, construction to operation, which started in December of 2015. Just to give an idea of kind of what the landscape looks for a desal plant, at least the Carlsbad plant, I wanted to show this slide. And here, our plant had the advantage of being able to co-locate with the Encina Power Station. It has a once-through cooling infrastructure in place, so it had the intake and discharge already in place, which we are utilizing for our desal plant. Water is pulled in from the power plant into the lagoon from the ocean, through the intake, it goes through their cooling process, and then out the outfall. We tap into that outfall piping or channel to bring 100 MGD of seawater to make 50 MGD of desalinated water. That process of co-location is no longer a viable option for desalination plants moving forward. We were kind of grandfathered into the new Ocean Plan Amendment from the state of California. So you won't be seeing this type of configuration in any new desalination plant that's developed moving on. Technology is going to be a part of today's panel discussion, and this plant, while it's definitely one of the most advanced seawater desalination plants in the world, it's a pretty standard process flow diagram. We pull in 100, like I said, 100 MGD of water. The pretreatment consists of floc basins, media filters. We have a second stage of pretreatment with cartridge filters, micronic filters. Then we go through the reverse osmosis membranes. That's the muscle in the plant that removes the salts. And then we have chemical addition, chlorine contact tank, and a product water tank. So the real kind of new thing about this plant that really made desalination viable in the U.S. and for our agency was the energy recovery infrastructure. This technology allows us to reduce the energy consumption for desalination by 30%. And that was a big driver of what made desalination infeasible for development in the U.S. was the cost of that. So that one technology that was added really made desalination viable for our agency and our customers. I want to move now to, we are also investigating a second desalination plant, the Camp Pendleton desal plant. We've completed some feasibility and some technical studies. It's showing that we could develop a 50 to 150 MGD plant up at Camp Pendleton. That's the northern part of our distribution area. There's a lot that still needs to be done here, and it is not forecasted as a near-term or even within our planning horizon. Our demands have gone down, so this is just a viable option that's out there. How we're handling this is called an adaptive management timeline, and I think this is what's important for agencies to look at is that there's a lot of things that play into making the decision of when to pull a trigger and when to start the development of a project. So our agency is decided that we're going to take these snapshots of what demands are looking like, what supply development looks like in our region, and we'll make decisions step by step so that we're not committing. There have been no dollars committed to a full-scale project for this project, but we'll continue to see if there is a time when that trigger does need to be pulled and make our best decision at that time. The other parts for the Water Authority we'll get into later on in the project. So, thank you.
Thank you very much, Jeremy. Our next speaker is Ray Hiemstra, who is the Associate Director of Orange County Coastkeeper. Come on up.
All right. Well, glad to be here. So, I'm Ray Hiemstra. I'm with Orange County Coastkeeper. We're an local environmental group focused on water quality. Part of the reason I'm here, though, is because this is a big issue for all of the environmental community. Desalination is a statewide issue, especially in California. It's a worldwide issue, and it's something that hits on a lot of different environmental issues. So we have a large coalition that's watching this stuff very closely. Includes NRDC, Sierra Club, Surf Rider, all of the keepers, Heal the Bay, you name it. Everybody's keeping an eye on this because it's going to be a big issue going forward. So the main focus for us, we're on the policy side of things, so we're generally not engineers, but we're commenting and want to make sure that good things happen for both the state and for the environment. So one of the things that we worked on really hard was the statewide desalination policy that went into effect in 2016. And as it says here, the overarching goal is to ensure California has a diverse water supply while protecting marine resources. It's very important. California is a leader in protection of marine resources. We have one of the largest networks of marine protected areas in the entire world. We worked really hard on those. And we actually had a policy that our coastal power plants are no longer going to be withdrawing coastal water for cooling because of the marine impact. So if we're going to be taking water out for drinking water and processing that, we're going to need to have a good policy for that. So we worked really hard on this with a lot of stakeholders from all the water districts, everybody. And what this basically says is that you're going to need to use the best site location, the best design, and make sure that you need the water when you're deciding whether you're going to have a desalination plant. And as you can see, there's a number of them proposed throughout the state. We've got our first test coming up with one that's going through the process right now. So our job is to make sure that the statewide policy is implemented as fully as possible so that California gets the best results from that. So what are we looking at overall? Why are we talking about desalination right now? There's a good reason why there's not a ton of desalination plants, large ones along the coast. That's because it's very difficult. Back in the 60s, President Kennedy said that if we could make desalinated water at a cost-effective rate, it would be one of the greatest achievements of mankind. In the meantime, we've put somebody on the moon. We're still not quite there with water yet. So we're working on this. We're coming along. We're putting up some plants, and we're making a lot of progress. But again, there's lots of different options. What we propose is a loading order. We want to make sure that conservation, recycling, stormwater capture, all those easier, cheaper things get done first. And the main reason is, at least from our perspective, is again, the environmental impacts. I have one slide here that focuses on the marine impacts. For instance, when we put in something, we can always say, well, we'll mitigate for those impacts, or we'll find some way to take care of the harm what we're doing. Up there on that little triangle, up there at the very top of that, when we do our mitigation for something, for like a desal plant, that's what we end up mitigating for. So we're really missing all of these impacts in here. So there's a lot of times you hear things like, well, it's not significant, or we've measured that, it's not that much. We're missing a lot of the impact that's going on. So that's why this is so important to the environmental community. And I want to make one statement really clear. We are not against ocean desalination. What we are is we're for good plants that are designed well and put where they're needed. And there's some of those out there, so, and then there's other ideas that aren't. So thank you.
Our next speaker is my colleague, Sonny Jain, who is the chair of the Department of Civil and Environmental Engineering.
All right, yes, I'm the homie here. I teach a class, a graduate class called Desalination. I see some of my students, past students are here. I'm really happy to see all the interest from the community, and maybe I can offer a graduate class and to all the visitors here. But what I really want to talk about today is to show you some of those technologies, and from the engineering process point, are we really ready for the prime time? So here is the desalination process. Everybody perhaps heard of the thermal desalination. Basically evaporate water and then make the water steam condense and then change back into clean water. That's how desalination work in 50% of the desalination plant in the world. And most of the Gulf Coast, and then using these thermal processes, there are two different massive thermal processes. One is called multi-stage flash, and the other is newer technology called the multi-effect distillation. Both of them generate tons of water, and actually they are the major desalinated water process in the world. And the other process is newer in the past 10 years, and then this have been taking a headway, and then all the newer desalination plants are basically membrane-based. And then under membrane-based technology, reverse osmosis, you already heard about it, is one of the technology of choice. And then electrodialysis is another membrane-based technology, is being applied in the small scale. And the reason why I want to present this is because all technologies there for desalination, they should be picked and chosen for different purposes because they have a different optimum range for this TDS, the total salt in the water. The distillation technology, basically the thermal technology, can handle very, very salty water. If you have Red Sea, have a huge amount of salt in there, and then you will have a lot of trouble to push that through a membrane. The membrane is a semi-permeable, you can think about that as basically semi-permeable plastic. It can push water molecules through, but salt, although it's dissolved, is still bigger than the water molecule. It wouldn't push through. You can push really, really hard with a lot of pressure. 900 pounds per square inches, you can push through the water and remove the salt. That's how the reverse osmosis work. And if you have very high salt concentration, you need more power to push that. That's all the energy consumption is coming from. And of course, those other technologies in here can handle very low salt. Brackish water from the groundwater are perfectly fine sometimes to use those other technologies in here. Hopefully that technology gave you a little bit of idea what are we talking about. The reason why the membrane technology have been taking the major height waves is because, well, let's do a comparison first, right? And then because everything you hear from United States is all on, this is called the seawater reverse osmosis. Seawater reverse osmosis require pure electricity. Electricity is the purest energy that is putting into the electric grid. It's a very expensive energy. And thermal desalination here, this is the MED, multi-effect distillation, multi-stage flash. They need steam pressure. If you create the steam pressure by burning fossil fuels, you take huge amount of energy. But if you have a waste steam coming from geothermal energy, from the geothermal steam, or you have a waste steam coming from a power plant cooling system, you may save actually money, not necessarily the energy. You take advantage of the steam. So if I do convert the steam energy into electricity, and of course it's very, very expensive. Look at this, is huge differences in there. Okay, so you're comparing this system, sometimes it's comparing apple to oranges, depends on where that steam energy is coming from. So I just want to point that out from the technical point, okay? Of course, if you just there also requires some electricity because of the pumping power required for moving water around. And then in our seawater reverse osmosis is really, they're just pure electricity. But if you look at that comparison, this adds up to be 10 times more than this. Of course, that people say thermal energy using thermal desalination is very expensive. It's coming from this comparison. But the range of prices, of course, there are different opinions, but the range of prices is mostly depends on where that steam pressure is coming from. Okay, I hope my point is clear in there. The reason why the membrane technology really taking off in the past 10 years is because in the past 40 years, look at this trend of the power consumption by membrane. We dropped 8 times because of material science, because how do we make membrane? We make this membrane so thin, you can press, the water goes through without too much resistance. So this is a current stage of the energy requirement for membrane. You see this dashed line in here? That's the theoretical energy that required to separate the salt from water. That means with all our current membrane technology, we're reaching that theoretical limit. We can change all the material science, all the chemical engineering, working really hard for the next 10 years. This is the maximum we can reach right here. This graph is basically showing that theoretical energy of 50% recovery of water depends on how much salt you have in the original water. Higher the salt is, you require more theoretical energy in that. The theoretical energy limit for most of the typical seawater of 35 parts per thousand salinity require about 1.1, 1.2 kilowatts per cubic meter of water. Okay, where currently can reach, our practical membrane can reach 1.8 kilowatts per kilowatts hours per cubic meter of water. So the membrane technology have really taken off in the past 10 years. Of course, the energy recovery system also brings some additional energy back. And this is a sort of a breakdown of cost. Don't think cost is only the energy, but there are also other costs involved in the desalination technology. The breakdown of this cost analysis, this is the membrane technology. The electricity is less in comparison with the energy for thermal desalination, but you have a lot more maintenance costs in there. So you need to look at the big picture of desalination technology in that. This is basically a schematic of simplified desalination membrane plant. Okay? In addition to the membrane, which is you already see in the presentation by Jeremy, this is the membrane. Reverse osmosis membrane, he called it the workhorse for desalination. Yes, it's workhorse. But if you look at the layout of the plant, there are pre-treatment. Pre-treatment is basically you have to treat this water, remove all those particulates and algae, bacteria, everything else in the seawater to sand before you can put it onto membrane. Otherwise, your membrane will get damaged. It's a $30 million of membrane in those desalination plant. You don't want them to be damaged. And this part also take money and take energy. So those lines are how much energy consumed in each process. Intake take some energy, and pre-treatment take pretty significant portion of it, of course, the workforce take a lot of energy. Higher salt you have in the seawater, higher energy you require. And dispose them also take energy. This is basically showing you the picture of how desalination works. There's a lot more opportunities to optimize the pretreatment. And so the bottom line is we have the technology. The membrane system have been used in many big desalination plants in Spain, in Israel, now in Australia. Now we have one of the largest one here in San Diego. And there's technology challenges. And for engineers, we deal with membrane fouling. I tell you, you need 900 psi to press this water molecule past that membrane. If you have anything clog that membrane, you need even higher pressure, that higher electricity cost. That's called membrane fouling. Membrane fouling is one of the big challenge for the theoretical operation of the desalination plant. Any environmental challenge, Ray said, yes. We have tons of problems. We have problem of the disposal of our brine. We have a problem in sucking up the juvenile fish or the larvae. And engineers are trying to do our best to understand those impacts, try to minimize impact. Those are our challenges. And carbon footprint, which is the energy requirement, that's a greenhouse gas. Can we use some of those waste heat and then combine maybe renewable energy to best use in desalination? Other opportunities is if we can integrate water, energy, and environmental management together. Let the power plant talk to us to make water. Can we use their waste heat to produce desalinated water? That will be the opportunity. Maybe that's a win-win situation for everybody. To conclude, I do feel like the technology are mature and ready for the prime time to help us to quench our thirst, and desalination should be viewed as an important component for all this water portfolio. You already see it coming, right? You like it or you not like it. If you don't have enough water, we don't have people, we don't have jobs, and a lot of people maybe in here have to move to somewhere else. So those are for water scarce regions such as Israel, such as the Middle Eastern area, you have to have desalination. That's the only source of water. So that's my more than 5 minutes of point. Thank you.
Our final speaker is Scott Maloney, who is Vice President for Poseidon Water. Scott, come on up.
Great. Good evening, folks. My name is Scott Maloney. I'm the Vice President of Project Development for Poseidon Water. Poseidon's a private company that's in the business of financing and developing water infrastructure projects. The company was founded in 1995. We're headquartered in Boston with offices throughout the country. We are the owners and developers of the Carlsbad desalination plant, which is the largest seawater desalination plant in the Western Hemisphere. We came online in December 2015 and produced about 24 billion gallons of drinking water since that time. We are also the developers and owners of the proposed Huntington Beach desalination plant, which is like Carlsbad, will produce 50 million gallons per day of drinking water, which is about 10% of Orange County's water supply, or about enough drinking water for 400,000 people. Most people believe that the future of desalination in the state will depend on whether or not we're successful getting the permits to build the Huntington Beach projects. It will be the second large-scale desalination plant in the state. Some of the opponents of seawater desalination have characterized Poseidon as the horse that got out of the barn. And I said, well, never let that happen again. I obviously don't agree with that characterization, but I do think it's accurate to say one desalination plant could be considered an anomaly. A second large-scale plant would represent a commitment on the part of the state to really diversify its supply. So one of the challenges of being last is you get to repeat everyone else's slides. So the question is, why desalination? It's a new local source of water. It reduces the need to import water. Depending on where you are in Southern California, you could be almost entirely dependent on water that comes from Northern California or the Colorado River, or less so. In Orange County, for example, it's about 50% dependent on imported water. In South Orange County, where there's no groundwater basin, it's over 90%. And in parts of Central and Northern Orange County, it could be as little as 20% dependent on imported water. In seawater desalination, the reverse osmosis process can produce a very high quality source of water. It's essentially designer water. You can make it whatever you need it to be. The TDS is half of that of Colorado River water, which is not very high quality water, but it is a large source of water here in Orange County. And finally, and maybe most important, it's climate resilient. It doesn't depend on snow in the Sierras, rain in the local mountains, or people flushing their toilets. The Pacific Ocean is the largest reservoir in the world. It's always full, and we have the technology to turn that water into drinking water in an environmentally responsible and a cost-competitive manner. As mentioned earlier, the state now has a policy or regulations for seawater desalination plant. First of its kind in the history of the state, the only regulations in the world that we're aware of that are specific to seawater desalination plants. As a result, California now regulates seawater desalination as a beneficial use of the Pacific Ocean. These policies or these regulations took effect in January of last year, and as Mr. Hiemstra says, it requires that every project, every desal plant, use the best available site, design, technology, and mitigation measures feasible to minimize the intake and mortality of all forms of marine life. That's the standard that everyone has to hit. So taking a step back of why are we doing this? I mean, is it really time for desalination? I mean, what does the state think about desalination? If you look at all the way from the top down to the local level, desalination is in the planning documents. The California Department of Water Resources prepares what's called the California Water Plan. It has identified desalination as one of the key resource management strategies within the state, capable of providing 400,000 acre-feet of water per year by 2030. I apologize, sometimes we get into jargon. An acre-foot is 326,000 gallons. It's about enough water for 2 households for a year. Governor Brown's Water Action Plan has, as one of the key strategies, regional water supply self-reliance. So no more depending on people far away for your water. Seawater desalination is one of the pillars of regional water supply self-reliance in the governor's plan. The Metropolitan Water District of Southern California, the major importer of water into Southern California, has identified the need for 2.4 million acre-feet of local supply by the year 2040. Desalination is part of that consideration, even with the California water fix, which looks like it may be on shaky grounds these days. And then here in Orange County, the 2 major regional agencies that are in charge of managing water in Orange County, the Orange County Water District that manages the groundwater basin, and the Municipal Water District of Orange County that imports water from Met, both have identified the Huntington Beach project as a future water supply, not the, but a future water supply for Orange County. This looks a lot like the pie chart you saw earlier, and again, it's just designed to illustrate where Orange County is trying to go. Poseidon and the Orange County Water District have entered into an agreement where OCWD would purchase the full capacity from the Huntington Beach project if we could successfully permit the facility. It would be a public-private partnership, just like Carlsbad, where Poseidon, the private developer and owner, is responsible for siting, permitting, designing, financing, constructing, and operating the desal plant. And OCWD is only responsible for purchasing water if we can deliver it, meeting contractual specifications. Why are they doing this? Orange County today has the largest wastewater recycling plant in the world. They recycle 100 million gallons of wastewater and inject it back into their groundwater basin. They're going to build that facility out to 130 million gallons per day. It is a model for everybody on water resource management. But what this is designed to show you is that they have a policy goal of diversifying their supply, enhancing reliability, and moving away from imported sources. So if you just look at 2005 and then to 2023, the whole thrust behind the Huntington Beach project is to reduce demand on imported water. It's not for growth. We're not trying to develop a new source for more people coming. It's to reduce one piece of the pie with another piece of the pie. One of the things I'll point out here is that the total demand, this is an OCWD slide that I borrowed for this presentation. In 2023, 455,000 acre feet is less than 2005, only slightly more than roughly what they're using today. So they're not projecting huge demand. There's going to be demand hardening. Conservation really is going to be a way of life in California. This is just the same data, just presented differently, but what it's showing is that OCWD in Orange County is trying to move away from climate-driven sources to more climate-resilient sources. The Carlsbad facility last year was designated by the State Water Board as a climate-resilient water supply because it didn't exacerbate the drought conditions. And as a result, San Diego was allowed to ratchet down the mandatory conservation and use more water because of the Carlsbad facility. That same promise holds for Orange County. You could see in 2004, only about 4% of OCWD's supply was climate resilient. With their final phase of GWRS and desal, they can get about half of their water supply as climate resilient. So just to close up, in summary, kind of what I see as the opportunities and challenges for desal, as a company that rightly or wrongly is kind of viewed as the face of desalination in California, we will be the first to tell you it's not a silver bullet, it's not a panacea, it's a tool in the toolbox. And it may not even be the first tool that you pull out of the toolbox, but it's absolutely going to be part of the state's supply going forward. We have an aging infrastructure. The water that comes to us today comes through facilities that were built 50, 60, 70 years ago. We have a lot of water quality issues with that water coming through that aging infrastructure. We have a growing population. 74% of the state's population resides in coastal communities. And climate change, the big one, climate change. Whether you're ready to accept it or not, it's getting drier, it's getting warmer, and we can't rely on the old sources of water. Challenges are that there's only so many sites you're going to be able to build a desalination plant. Facilities that use subsurface intakes, meaning you get the water from the aquifer below the ocean floor, which is the preferred approach by state regulators, are going to require very unique geological and hydrogeological conditions. It's also going to limit the capacity of those plants. Larger plants like we're proposing, you're going to need a good-sized industrial piece of property along the coast. So you're not going to see the coast of California dotted with desalination plants. It's not going to happen. State regulations. We introduced our projects in 1998. Huntington Beach just came on, our Carlsbad just came online in 2015. Huntington Beach is still in the permitting process. As a private entity, we spent over $100 million developing, permitting those two projects with no guarantee of a return. There's a huge barrier to entry for both private and public interest to bring desal online. And then political leadership. Nothing gets done unless there's a crisis, right? We've learned that the hard way. When there's a crisis, bad decisions are made. And so our hope is with this new policy in place, there's a roadmap to responsibly site, design, and build desalination plants. So, thank you very much.
While the cards are being collected, I have previously pitched to all of our panelists a question that they've had some time to reflect on. And in fact, in our excellent presentations, this issue has been touched upon. Portfolio approaches, diversification, trade-offs, and so forth. The question which I'd like each of you to spend a couple of minutes addressing is the following. What is the optimal role for desalination in California's water supply future, specifically its role relative to other options on the table? And of course, each of you have alluded to other options. Newsha, why don't we start with you?
Desalination is a very locally relevant topic. Not every region, not every community needs desalination. I'll give you an example. During the 80s drought, Santa Barbara was very interested to create this climate resilient, drought resilient solution because actually they were having a lot of water issues. So they actually built the desalination plant. As soon as they finished the project, the drought ended. And as you heard, desal is a very expensive source of water, and it was not cost effective for them to run the desalination plant. So they turned it off. The problem is, it's not like a switch, you turn it off and then you turn it on when you want it back. You have to maintain the systems, and actually I really like Sonny's slide that showed there's a big, if you have noticed, there was a big chunk of that pie that was maintenance and operation, and you still need to maintain that maintenance and operation, and that there's some energy that goes with that. So then at the end, basically, they decided they dismantled the whole system. They sold it to Emirates, and then the drought happened again, and they started rebuilding it again. So there's a big challenge because these systems are not something that you need them all the time. And the reason I mentioned that story is we have so many other options. So conservation efficiency is the first layer, cheapest, easiest, And actually, our water supply, demand for our water supply in the past 20, 30 years, even though constantly have been projected that it would increase, it has not increased. We have been using the same amount of water in the past 30 years that we are using today. Some communities actually are using even less. And this is before the drought that happened. Right now, a lot of water utilities, and I'm sure you can attest to that, it's people are not using as much water you used to. So demand is a very sensitive issue and a very important issue when they're deciding about desalination. One last point I want to make, it's demand, and then after that you do conservation and efficiency. You can do stormwater capture much cheaper, then you go to recycling and reuse, and then desalination, partly because of the cost, partly because it's not a turn-on, turn-off option, and it is an expensive process, costs so much to build, costs so much to maintain, and adds a lot of, and doesn't necessarily take a lot of pressure off our existing water supplies that we have, actually. And I have some numbers which I would love to go back to them later.
Thank you, Newsha. Jeremy?
I think you're going to hear a lot of similar things from most of the panel members here, that there isn't really a set priority of water supply development, and it's going to be appropriate for everybody in the state of California. It's a localized scenario that you have to look at all the conditions. What are your existing supplies? What are your risks to those supplies? What is your geology? What are your available new supply sources? And then from there, that there's political will, there's public public influence, cost. There's so many different things that feed into differently for the different supply options. For the Water Authority, as I mentioned in my presentation, when we decided to really get behind the Carlsbad plant and get in the implementation of that, we had looked at conservation and all the low-hanging fruit of conservation we had applied. Our demands at the Water Authority, as she mentioned, they're low. We were in our peaks. We were selling 600,000 acre-feet of water in a year. We're down into 400 acre-feet. Our population is growing, but conservation has been very effective. But conservation, every time you look for the new step or the new thing to conserve, it gets a little more challenging and a little more difficult, a little more expensive. So, you have to look at everything. And so conservation is the first thing, and we fully agree and have implemented that at our agency. We've put in desalination. We have a viable desalination plant that could be our next water supply. But that's not the direction that we're going. We have now prioritized potable reuse and the advantages and the drive, the support of the public of that supply is now where our region is focused. So it changes over time. It changes by region, and you need to be very flexible and adaptive to what those changing environmental factors, demand changes, and your supply opportunities, and that's just very key. And when you're making decisions to invest big money for all these new supply options, we're going to need more water moving forward, and there isn't a really cheap option out there for any of us.
Thank you, Jeremy. Ray?
From the environmental perspective, what we're looking at is for desalination to play the same role it plays right now, which is the role of last resort. Where we see it are places like the Middle East and Israel, where they have, very limited water supplies, and people have really conserved as much as possible. The average water use per capita in Israel is 50 gallons per person per day, where in Orange County it's well over 100. So we have a long ways to go. For instance, we spend 60% of the water that we use in Orange County on landscaping. So, when there's ideas about that we're actually going to run out of water here in Orange County for industrial uses or drinking or personal use, that's just unrealistic. We have a long ways to go with that. But there are places, and for instance, even in Orange County, there's a diversity of where we get our supply from. As mentioned, in South Orange County, 90% of that water comes in, it's all imported water. In the northern part of Orange County, 75% of it comes from groundwater. So where do you want to place these things? It's going to be very important to identify where you really need it. Have you done everything you absolutely can to avoid it? And then you go ahead and go there. Because you don't want to end up with a stranded asset issue. Got mentioned Santa Barbara. A much bigger example of stranded assets is in Australia, where they built 6 really huge plants, and 4 of those are shut down now. So it's one of those things you want to carefully think out, because it's a big step and you want to make sure you make the right one.
Thank you. Sonny?
Well, I'm more a technology person rather than a water policy person, but I definitely see a role of desalination to make a secure water supplies. Yes, Ray just mentioned Australia. I had a 3-year appointment in Perth, Australia. Has 2 largest desalination plant in Australia as continued operation, and bigger the desalination plant is cheaper it gets, and also they use a lot of wind energy to supply the energy for the desalination after they built the first one, and it's a very successful source of water supply, stable water supply, and then they move in with the second one. And so I was there pretty much for technical type of work and to reduce, optimize the sort of the environmental impact, optimize the process, reduce the environmental impact. I definitely see a role of desalination play. You can't wait till you're running out of water to build a desalination plant because it's too late. It doesn't come immediately. And then if we can diversify our water portfolio and make desalination play a role, that will be a secure card in our water needs. That's my view.
Go ahead, Scott.
Yeah, I think looking into the crystal ball, desalination may be 15 or 20% of the municipal and industrial demand in the future. It's not going to be a huge component of the water supply, but I think it'll be an integral component of the water supply. I agree it's a very local decision. One of the things that I would object to or resist, and I think it's true of the local water, regional water agencies, is this idea that Ray mentioned of a loading order or some kind of top-down directive that you have to do conservation, then recycling, then stormwater capture, and then whatever other politically popular issues before you get to desal. We believe it should be left to the local and regional decision makers and water managers to make that decision, because every local or regional area will have a different opportunity, different resources to manage. The historical impediment to desal has been cost, has been raised. Today in Carlsbad, the largest, most technologically advanced desal plant in the Western Hemisphere, we're producing a gallon of drinking water for half a penny. Probably takes another 2-3 tenths of a penny to deliver that water from Carlsbad into the regional system. In comparison, imported water is probably 2 or 3 tenths of a penny. And so water historically has been cheap, artificially cheap or inexpensive. And that's changing. If you go back to 1974 and you look at the average annual escalation of imported water into Southern California, it's about 6.5% a year. Hasn't done that every year, but if you flatten the curve, its average is about 6.5%. And so I agree that the days of inexpensive or cheap water are over. I think that's why the Carlsbad project has been embraced. The average household in San Diego has seen their water bill go up about $4.50 since the Carlsbad plant has come online, and we've not heard one complaint. I don't think the Water Authority has heard one complaint. I mean, that's a couple Starbucks for a drought-proof, reliable water supply. And the last thing I'd say is that we have never viewed the drought as a reason to build a desal plant. You hear me talk about drought resilient, drought proof, but I mentioned that we introduced our projects in the late 90s. Carlsbad just came online a few years ago. Huntington Beach is still trudging through the permitting process. We've been in and out of drought 3 or 4 times over that period. No one is going to build a desal plant in time to relieve pressure from an immediate drought. That's not what our projects are about. It's about diversification. It's about local control. It's about reliability.
All right, thank you, panelists. We have some excellent questions that have been submitted by the audience, and Shannon has helped me winnow down and making sure that we get a broad range of issues covered, and of course a number of duplicate questions. I want to start out with a very important and very direct question for all of the panelists. What do you see as the biggest single challenge to building effective desalination plants? Is it technology, regulation, social responses, politics, or something else? Who wants to start?
You can go in reverse order.
We can do that.
The biggest challenge would probably be the availability of affordable and green power. One of the challenges that, or one of the concerns that has been raised is that desalination uses a lot of energy. And you saw Ray's slide where he had a desal plant and it depicted these stacks spewing emissions in the air. The reverse osmosis desalination process does not have any emissions. And that's a caricature to help Ray make his argument. But we do use a lot of electricity, and we have to buy that electricity off the grid. Currently, the state prohibits us as an industrial user from entering into a direct power purchase agreement with a renewable energy provider. We would love to power our facilities with green power, but we're not allowed to. State stands in the way of that. We have to buy our electricity off the grid, and so we get a mix of green and fossil fuel electricity. That electricity is also expensive. One of the reasons why desal in other countries isn't as expensive is because the cost of power isn't as expensive, and in California it is, and so it makes the overall cost of the water expensive. Electricity is about 50% of the cost to operate a plant, about 25% of the overall cost of desal. So I think the challenge in the future will be the availability of affordable and green power, and it's not unique to desal. You know, we import water into Southern California from far away, and that takes a lot of energy too, and that's expensive.
Well, my answer is that I definitely don't think it's technology. And we have the technology to desalinate, but effectively reduce the greenhouse gas is one of the challenge. And certainly there's a lot of room to improve in many different aspects, and collaboration between water agency, power agency, and environmental group. That's, I think, an important challenge to face and important opportunity to make the desalination more efficient. So that's my answer to this brief question.
The biggest challenge by far is cost. As an environmentalist, we get run over all the time on different plants, and the only reason this one's taken 17 years to get as far as it has is because it's really expensive. So, you know, the main thing is trying to find somebody who's going to pay that double the price of imported water or 6 times the price of groundwater, and actually, you know, pushing it through that way. So the regulatory hurdles and things like that, Santa Barbara demonstrated that, you know, when they decided that they needed to rebuild their plant again, they had it up and running in less than 2 years, and it was, you know, a quick move. When things need to move quick, they can move quick. They haven't so far because of the numerous challenges. But the primary one, I will say, if it wasn't for the cost of desalinated water, there'd be a lot more desal plants out there.
I want to address kind of Ray's cost component a little bit. I mean, again, cost is a local decision as well. And, you know, at our Carlsbad plant, we're about twice the cost of imported water, and that's been known since we laid out that groundwork to our ratepayers and got the support of our ratepayers that the benefits of that water supply were appreciated and were more important than the cost of that water for our ratepayers. So again, I think the cost, yes, it is more expensive, but again, it's a local decision, and if you have the support for it, then the benefits outweigh those cost issues. But for me, I say regulatory and the permitting process. I know Ray and Sonny both mentioned the Ocean Plan Amendment, and even Sonny was talking about that it helps kind of streamline and lay out the groundwork of how to regulate and how to permit a desal plant here in California. But it's a new regulation, and even the regulators are still learning how to implement the rules and the guidance and the expectations in those regulations. We're currently doing a pilot program for our Camp Pendleton project, and it's looking at different intakes. The Ocean Plan Amendment prioritizes subsurface intake, Our pilot study is to specifically compare open ocean intake with subsurface intake, with the hypothesis that for our geology at Camp Pendleton, that subsurface may be an economically feasible alternative to open ocean, which is the guidance and the direction that the environmentalists and the Ocean Plan Amendment are going. Yet to permit a 20 gallon per minute, that's really, really, really small pilot facility. We're now working on our third year of trying to permit just this pilot facility to get data and research and information that is going to help guide regulators, the permitting process, the industry, and viable data even for the environmentalists on what does subsurface do and can it be economically viable, so that we can start implementing that at some of these key locations within California. So regulations, we're making good steps forward, but there's still a lot of improvements to really be able to permit, and we just want to know what the expectations are. And right now, that's still in flux a little bit as you try to permit a desalination facility.
Okay, so it's fun to go last, so then I can touch on a lot of other points. So permitting came up multiple times. 15 years it took for Poseidon to build Carlsbad. Only 3 of those years was permitting. The rest was trying to figure out their financing, finding a buyer, trying to figure out who would buy. And Scott mentioned that when a public-private partnership happens, they are not looking for a drought solution. They're looking for someone who would continuously be willing to buy a certain amount of water annually, because that's how these systems can be run. Otherwise, if it's a public source, then you know you can't turn it off and on. But if it's like somebody else owns it, you have to pay for it, right? So, so that's one issue. Australia came up multiple times. Israel came up multiple times. Those are all publicly owned desalination plants. Eastern Australia came out of the drought. They shut off all their desalination plants. They were expensive. They couldn't run them. They did not want to run them. They have cheaper options. However, the Western Australia that Sonny mentioned, Perth still is experiencing drought, so they kept their desal plot going. Just to give you perspective, Perth, the population of Perth is 2.5 million. So and we'll talk about Israel, which is a country of 8 million, right? And they do and Ray mentioned their water use is 50 gallons per person per day. Just think about that and think about the amount of water we use here and the population. So there's a lot of things to compare. So, and I know Scott mentioned that if we find cheaper power, electricity, this becomes cheaper. That's not necessarily true. You need to, land is expensive here. So the cost of building, financing, buying land, maintaining and operating, and also the fact that you have to buy it continuously is expensive. I think for sure, a couple of things that are very important, I think personally, is technology is important. Obama administration, at the end of their period, they were trying to actually focus on desal. They put a lot of money. I don't know if that money ever will happen, like end up being distributed, but they allocated about $200 million in the last year to invest in desalination technology. They wanted to do a moonshot for desal to see if they can invest in this technology and see if they can find a cheaper way of doing desalination. And technology is important, but then again, technology and need, right? So if you don't need, if the only times you need that water is during the drought, then why would you pay twice as much as your local supplies for something? And I think, Jeremy mentioned that it's a local decision. There was a lot of politics involved in the San Diego desalination project. It was not a black and white, we wanted to have a desalination plan. So it was a 15-year process with a lot of different stories in every one of those years, which is worth looking into in case you are interested.
Just to correct the record, because I'm an employee of the company, the permitting of Carlsbad started in 2001, and we didn't get the last permit we needed issued until 2010. So it was not a 3-year process. Over those years, there were 14 legal challenges filed by environmental organizations. All 14 were dismissed. So absolutely, the regulatory environment is stifling in this state. I don't think you're going to find very many people that would disagree with that. That's the fact.
Can I say something? Okay, so I want to clarify. The 2001 to 2000, what do you say, 10? Only 36 months of those periods, State Water Board was permitting this desal process. You can go and look online. That's only, so maybe it was hurdles during the process because they had to deal with the legal challenges, but only 36 months. One other thing I want to mention to you, I've sat on a lot of desalination panels with people from other countries, including someone from Israel a couple of years ago. And we kept talking about cost, and at the end he said, look, we care about the environment, we care about our people more than environment. So we don't care how we pull the water out of the Mediterranean Sea, and we don't care how we dump it out, because it's okay if a bunch of fish dies. It's important to supply water to our population, and that's a local decision. Again, that is their priority. The Californians, we have different. I mean, at least I think we do, since the way we vote and everything, it defines what we care about. We have different priorities. So you can care or not care, but the reality is the protection of their ecosystem and what we have here, the beauty of our state, depends on a lot of these protections. And yes, permitting can become a better, more modernized and more streamlined. I'm not saying it's not a hurdle, but I don't think it's the only hurdle. That was my point there.
Thank you very much. Great discussion, and this discussion is a very good segue to another audience question. We're now coming up on the 2-year horizon that the Carlsbad plant has been in operation, December 2015, December 2017. Question for all of you. What advice would you give to various water agencies throughout the state that are looking at desalination based on the Carlsbad experience? Who would like to start?
Jeremy?
That's a great question. There have certainly been a lot of lessons learned on the Carlsbad plant, and just operationally being the first kind of large-scale desal plant on the Pacific coast here in the California coast. There was a lot of lessons learned and how to operate a desal plant and protect your membranes. And we have experienced some of those challenges at our Carlsbad plant that have caused some reductions in capacity of the plant or some downtime of the plant. Specifically, we had an algal bloom event back in February and March of this year, and the fouling that it caused on our membranes, our clean-in-place process wasn't able to keep up, and so we had to enter into a membrane replacement program. And these are lessons learned that any new facility goes through. Whether it's a traditional conventional treatment plant, taking raw water from our imported system, or now desalination, you have these lessons that you learn. And I think you need to look, that there are a lot of lessons to take from Carlsbad, and I'll focus on just the operational side of things, of getting to know your feed water properties, getting all the the warnings and the monitoring of your feed water coming in, and learning from what we went through at Carlsbad to better supply your system and get your system ready for those algal bloom, red tide events, algal bloom events that we have here in Southern California. Just because IDE has successfully operated a lot of desal plants around the world, didn't mean they were ready to operate down in Carlsbad. And so there's some lessons to be learned there, and there are a lot of other lessons too, but I'll keep it at that for now.
Jump in that, yes, I have been working at the Carlsbad pilot when they started about 2008. I tell them over and over again, fouling is a problem. We'll do a side stream to monitoring the fouling and all that different technologies. And then you mentioned about the DOE, big desalination hub. It's basically looking at the technology. Actually, I'm really happy to see the Carlsbad having the problem they're having. It means there's a lot of room to improve in the engineering processes and optimizations and technology. Oh, I want to say, look, what I told you. And then so we visited this is the engineer, right? And the engineer said, we predicted all these issues. And then actually, there's the same problem with the pre-treatment in Tampa Bay. I don't want to bring that issue up. And then, so all that pre-treatment is the engineering optimization. And then we're developing new engineering technologies to be a smart sensor system to sense the fouling potential to protect the membrane, and then also using additional dissolved air flotation to get rid of the algae. I talked about all that in my report, and then funded by Water Reuse Foundation, using the pilot facility in the Carlsbad to do that research. So we learned a lot, and then learned a lot from the engineer perspective of how to better design and better treat and then better monitoring, and have the membrane have the self-cleaning ability, and then self-reporting of the fouling capacity, rather than you fall to the degree that you cannot clean anymore, you have to do membrane replacement, that huge amount of money. And so those are potential proposals. We're going to submit it to the DOE Desalination Hub. We learned a lot. I'm happy with that.
One of the first things to realize about desalination is it's one of those things that looks really simple. You've got a big ocean. Why don't we just go ahead and make some water out of it? There's nothing simple about desalination. I've worked for decades in manufacturing. We ran tons of machines. Nothing ever ran perfect all the time. It was a matter of how well were things running, how did we manage our systems, how did we get what we could get out of the system. So that's what we're seeing in Carlsbad. Right in 2016, they delivered about 90% of the water that they projected. In 2017, the latest number I heard is they were at about 70%. I'm not saying that to diss them. It's just, that's the way things go, especially when they're new. But you can't expect things to run perfectly all the time. Some of the modeling doesn't come out the way that you expected it to. For instance, we had there's water quality issues. There's a permit that's required, issued from the Regional Water Board. They're having trouble meeting the requirements of their permit. That hopefully will be fixed. It's something that needs to be worked on. But it's as Scott said, it's not a silver bullet. It's just it's something out there that's just a machine. It's going to run. Sometimes it's going to work. Sometimes it's not. And so that, there's a lot of lessons to be learned. One of the things at Orange County Water District, one of the directors said, let's see the thing run for a while to see what we really get. We're getting our first real look at large-scale desal in the United States.
Sorry. So I think everybody else mentioned all the important issues, the lessons learned. One of the things I'm very excited about the Carlsbad project is it's one of the only projects that it was required for them to, and correct me if I'm wrong, to collect some data beforehand, before the desalination goes into operation, and now they're collecting data afterwards, right? Isn't that so that was one of the reasons they were trying to kind of set it up in a way that they can understand how it's going to function. And I think that was a very wise push from the state, and I'm so excited to see how it's going to come out, because that's going to help us. Actually, that is going to help technology improvement from intake, from outflow, from all the different parts of the desalination process that we need to go through. One other thing I want to mention is we mentioned about local supply multiple times. It's very important for different localities to decide if they want to have a desal or not. There's a region in California, Central California, that really, really can benefit from a desalination. The community is not as interested. They have voted down desalination multiple times, but they are one of the communities that actually, it is there. It has to be, desalination needs to become one of their options in the portfolio because they really don't have a lot of water locally, and they're not connected to any of our water arteries throughout the state.
I guess if I was advising an entity, an agency on what they should consider, it would be how to deliver their project. And by that, I mean, do they want to have a public-private partnership, or do they want to deliver it through more of a traditional government procurement? Large infrastructure projects in California and the United States are typically or historically have been delivered through a public design-build process. Around the world, you see a lot more P3s, public-private partnerships, especially in transportation and power, and you're starting to see it in water. One of the unique aspects of Carlsbad is it was delivered under a public-private partnership approach, which allowed the water authority and its ratepayers to shift the risk of not only developing and permitting and building the facility, but also operating it. And so we talked a little bit tonight about this algal bloom that required us to shut down the plant. That algal bloom would have shut down the plant whether Poseidon owned and operated the plant or the county water authority owned and operated the plant. But the distinction was there's no financial cost to the water authority and its ratepayers because under our agreement, they only pay for water that's delivered. And so as a result, they were insulated from that cost and that risk. And in fact, we actually, under our agreement, had to pay them for the fact that we failed to deliver water under the contract. When was the last time a state agency paid a local agency money for failing to deliver water they were expecting? So it's just a different approach. It's not for everybody. There's some downsides to the P3 approach. If you want to have complete control over a project, you're going to lose some of that control because you can't shift the risk and then also have control over all aspects of building and operating. So that's a big issue. There's a number of public agencies now that are looking at desal plants and trying to figure out what's the best delivery method, a P3 or public design build approach, and those decisions are going on not only in desal but wastewater recycling. So I would say that's probably the advice I'd give, and it takes a lot of thoughtful consideration because not everyone's the same.
Thank you all. I want to shift to an environmental impact question the audience has raised. Let me first of all read the question and then make a comment and observation. Many speakers talked about minimizing environmental impacts of desalination. Is it possible to completely mitigate desalination's environmental impacts? If not, why not? And let me simply say, acknowledging, as you've all already acknowledged, that every water supply option has environmental impacts. Who'd like to begin?
Come on, Ray. This is right up your alley, man.
Well, I'd say first of all, the number one thing we can do to mitigate for all of our water uses is to really be careful about how we use it and how much we're using. So, if you're going to build a desalination plant, you're going to have environmental impacts. There's no doubt about that at all. So the decision from our perspective, do you really need to build it? How big does it really need to be? And then what kind of technology do you use? So we have a good example of that in Orange County. We actually have two proposals in Orange County. One in South Orange County is smaller. It's located where they import 90% of their water. They're proposing to use subsurface wells and then commingle the brine with their wastewater outfall. So that minimizes a lot of the impacts right there. It minimizes a lot of the impacts to marine life from being sucked in. By commingling with the brine with an existing outfall, you're not creating a new pollution source. And by being small, you just have a smaller footprint. So that's one of the primary things you can do is just identify your real need and then build using the best technology to that need.
Yeah, Ray mentioned the Dana Point and Slant Well. Yes, the idea of subsurface intake is great. I worked on that, the phase 3 as well, and there is a problem with the connection with the seawater, and then so the groundwater is not connecting with seawater by the current well. So I see the subsurface intake, yes, mitigate impingement, entrainment of marine life, and perhaps the the discharge is a great idea, but I feel that process perhaps costs a lot more money, a lot more energy, and then if you're looking at the greenhouse gas emission and the other capital costs, there is still a cost associated with that. I will say, let's look at things integrated. Look at all energy, water, and environmental impact together. And so I do believe engineering approach, especially with the discussion with the environmental group and those broad audience, and take us, make everybody step back to look, can we do this better? And then the Israel example is in the early part of the desalination, there's no outfall whatsoever, there's no diffusers, they just dump right at the coast, because at that time they don't realize that. All that realization in California really push the engineers, the designers, to make the best that we can do to minimize the environmental impact, no matter it is intake or discharge. And then we can do better. And just as all the other technology, tunneling water from Northern California, and whatever technology, recycle and reuse, they all have certain degree of environmental impact. And to balance that, engineers can do better. We have a lot of students here. We can all help to improve, and that's my 2 cents.
So I think I touched on environmental issues multiple times. So I think I'll echo what Ray said and what Sonny said. At the end of the day, everything that we do can have environmental impact. The most important thing is to be mindful the way you use your water, and think about how you can use less water. And I'm not saying this just because I know this is a very environmentally focused topic. Everybody thinks environmental is constantly pushed, but I'm an academic. I'm not an environmentalist. But the true issue here is every drop of water we use, it's degraded. Okay, so it's basically it loses its quality. So the less we use, the less environmental impact we have. So when it comes to desalination, again, we really still, as Sonny said, and Scott mentioned too, we are still in the early times of desalination. All these countries that were early adopters, the one in Persian Gulf and also Israel, they adopted desalination much earlier. So the technology wasn't there. We did not understand how it can impact the what are the marine impacts. So, and it's very hard to go back and change. It's costly. So I think we have come a long way. I think we still have a long way to go, but it is an issue, and it's with every single drop of water we use.
The answer is yes. Not only are you permitted to mitigate those environmental impacts, but you can mitigate those impacts. I put up the excerpt of the state statute that guides the regulation of desal plants. It says, best available site, design, technology, and mitigation measures feasible. In, I think it was 2009, Coastkeeper, the San Diego chapter of Coastkeeper, not Ray's chapter, sued the San Diego Water Board over the permit they issued to the Carlsbad plant, alleging that we weren't allowed to mitigate for the unavoidable impacts in Carlsbad. That lawsuit went all the way up to the appeals court, and the appeals court sided with the water board that you're allowed to mitigate. In fact, that appeals court ruling informed in large part the desal policy, that it's a combination of site design, technology, and mitigation to avoid the impact and mortality of all forms of marine life. We're talking a lot about different types of seawater intakes. There's 2 marine life effects that are regulated and people are concerned about. One is called impingement, and that is when marine life, based on the velocity of the water coming into an intake, get pressed up against screens and there's injury or mortality. The new state regulations require that a quote-unquote ocean intake has to be screened with slots that are 1 millimeter, which is 1/25th of an inch, and that the velocity through those slots has to be ½ foot per second or less. So you eliminate the effect of impingement because of the slow velocity through the screens. The effect that you're left with is called entrainment. That's the other impact that is heavily regulated and a big concern. Entrainment are microscopic organisms, larvae plankton, that are small enough to get through a 1 millimeter screen. They get into the intake, and there's assumed to be 100% mortality. You can correct me if I'm wrong, Ray, but I don't think entrainment is an effect that's regulated in streams and rivers or anywhere else. It's only regulated in the ocean, so it's unique to desal plants. In Huntington Beach, Why we believe it's one of the best sites in Southern California for a desal plant is because there's no marine protected areas, areas of special biological significance, or hard bottom or kelp reefs offshore in the vicinity of our screened open intake. And as a result, for every 1,000 gallons of seawater, we will entrain 2 fish eggs, 2. Regardless of whether you think that's significant or not, we have to mitigate because those are the regulations. And what we propose to do is for the operating life of the Huntington Beach project is to dredge the inlet at Bolsa Chica, the largest restored wetlands in Southern California, hundreds and hundreds of acres of habitat. Without somebody agreeing to dredge that inlet, it's going to naturally silt up and close and that habitat will be lost. So my point is, we believe that it's a net environmental benefit, our project. Not only can we avoid or minimize the impacts, but we can then mitigate to a greater environmental benefit.
Thank you. Jeremy, last word.
I really don't have much to add to that. I think that in us trying to permit projects, we just want to know what the criteria and what the expectations are, and then use our engineering technologies and things to achieve those goals, or then look at ways to mitigate them. I think the environmental community and researchers here in California, they do a great job of identifying what the potential impacts are and what levels of protections need to be incorporated, and those are then put into the regulations that we have to abide by and to get our permits. And I think that there's a synergy there that we need to just, instead of being pushing up against each other and just arguing about, hey, this is what needs to be done and this is how, no, that's not going to work, that we can all come together and agree that we're in California, we do care about our environment, and we want to protect the ocean and protect the marine environment. But at the same time, there are other needs that power needs, water needs, that need projects and need access to these areas. And so knowing what those expectations are, wherever that bar is set, and I don't think that you're looking for us to say the bar can't be super high like it is in California, but let's just hold that bar, identify ways that we can approach, adapt, and meet those expectations, and then move on and develop those projects if they are needed and to what level and size they are needed. But the back and forth that often happens in some of these panel discussions or in the permitting process or the lawsuits that ensue from this, I think a lot of that can be avoided if we all look at the achievable goal and kind of apply our best skill sets that we each have to accomplish that.
Great place to end. We could go on for another hour and a half, but I think this has been an extremely illuminating discussion, great perspectives. We do have a reception out in the lobby, so stick around, introduce yourself to our panelists. Let's continue the discussion. Enjoy the rest of the evening. Let's give it up for our panelists.